Good day, Algebra. We are kicking off the week with CO4, halfway through our unit after today. I think it goes through 8. I can write, interpret, and evaluate algebraic expressions. You've had experience with this before, but it's worth going over again because, I understand that word problems are tough, right? When it comes to math, a lot of folks kind of just have that negative feeling towards fractions and word problems, okay? Fractions, because there are lots of rules that change depending on the operation. And word problems, because you have to set it up yourself, right? You have to somehow convert the verbiage to the numerical, right? Set it up correctly, and then solve it correctly. There's just those extra steps. But we were talking about, the real world earlier as far as teamwork versus individual stuff. Well, word problems are the real world, right? Very rarely do you have an equation just appear in front of you that you are told to solve. You've got to kind of decide, what do I need to do with the information I have, and how do I solve it? So very, very topical, which is why we have the math packets and things like that. It's a lot of wordy stuff. But anyway, so if you recognize this table from last year, you are not wrong. You're not just seeing things. You have talked about this before. But let's define first expression and variable. What is an expression in the mathematical sense? Not a facial expression, but a mathematical expression.
A word, a problem.
I prefer to call them opportunities. Expression?
Like,
Hugo?
like not an equation, but something that has like a numbers and operations that have a value.
Okay.
An equation without an equal sign.
Okay, therefore it's not an equation, right? What makes an equation is the equal sign. If it doesn't have an equal sign, it's called an expression. It's basically a mathematical statement.
Mathematical is a weird word. I don't like that word.
Well, then just put mathy. A mathy statement, if that suits your feelings. Okay. A mathematical statement. And the fact that it doesn't have an equal sign, right? Something can only have value when we assign it value, right? And we assign an expression value by giving it an equal sign, but just by itself is an expression, a mathematical statement. And a variable is usually a letter. It could be a symbol. It could just be like an empty box, right? But it represents
Like a number that can change.
Okay. Science, when you do a science experiment, right, your variable is things that you can change. In math, when we want to test an expression with a variable, we can plug different things in and see what will happen. What will happen if I add this much sugar to my cupcakes or this much sugar to my pizza, right? But a variable is an unknown value, and it is usually a letter. But really, it could be anything. That's supposed to be a U, by the way, not a C. There you go. An unknown value, usually a letter. And if you take a peek at the expressions on the page, you'll see I use the phrase unnumbered, right? That's where you would plug in a variable. Addition, subtraction, multiplication, division. Let's fill this table out. What are some different words or phrases that mean the 4 operations? I'm going to scoot this down a little bit so you can see some of what's down below here. And it'd be helpful to pick out some of the phrases that you see on the page so that you'll know when you get to that what category it belongs to. James?
Greater than?
Greater than. I'm going to use the phrase more than. Okay, that goes with addition. And then I'll put less than in subtraction because they kind of go hand in hand, but I want you to star it. Okay, because less than is a little bit of a tricky one. Okay, and I'll explain why here. If I tell you, 10, I'll use the typical word for subtraction, 10 minus 8. Okay, what is 10 minus 8 equal?
2.
2, right? You would take 10 minus 8. But if I gave you 10 less than 8, Is that still 2?
Yes.
It's negative 2, right? Less than means subtraction, but the way it's worded, it's actually going to be reversed when you write it as an expression. 10 less than 8 means you're starting with 8. And you take 10 less than that. So this would actually be 8 minus 10. And it's tricky because if all you focus on is the less than and then the operation of subtraction, you might miss the fact that it's actually opposite of how it's worded. Which is why word problems are tough. Okay? Because even if you understand what the numbers and what the operations are, putting it together can be difficult. Evelyn.
Add.
Oh, we're moving on. Add. And we'll say added 2, because you really wouldn't say something like, 15 add 5, right? You wouldn't know what you mean, but 15 added to 5 might be better. Yeah. Difference, what does that go under? Subtraction. The difference of. Difference means the change. Change means subtraction as well. Okay, these are good. Gus? Sum, where does that go?
Add.
Addition. And I'm going to put total also. Typically when you see the word total, it means that you are adding. That one's kind of interchangeable. Like you could say the total of 7 times 6. But if you just say the total of, it's typically adding. If you ever been to Target, right, you got your receipt down at the bottom, it says total. They got that total by adding all the prices together. Okay, so sum or total. Good. Tatum. Product, where's that go? Our first multiplication. Very good. The answer to a multiplication. And as long as we're at it, what's the answer to a division? What word goes there? Quotient is correct. Quotient is quotient. Yeah, tricky one. No SH in there. It's not KWOSHENT. No. Yeah. Divided by. For division, we'll put multiplied by. For multiplication. Chance?
For multiplication times.
Times. Okay. And I'll fill out the last one just to make sure that we have it. Words like double or triple mean multiplication as well, right? If you double something, you multiply by 2, triple something, multiply by 3. What's the equivalent for division here? Like the division equivalent for doubling and tripling. What words would kind of mean the opposite of that? I've got to go on. You go.
Undoubling.
Half, third, fourth, so on and so forth.
Undoubling.
Right? If you take half of something, you're dividing it by 2. You take a third of something, you're dividing it by 3. So those kind of go hand in hand there. What else you got? Impress me. James? Minus. That is correct. I'm not going to put it up there, though, because I've got one more trick with subtraction that makes it tricky. It's the phrases subtracted by versus subtracted from. Okay? Subtracted by versus subtracted from. One of these gets a little red star like less than did. Which one? Which one's going to have the opposite order of the way it's written? 10 subtracted by 8 or 10 subtracted from 8? Which one's going to flip that order around? From. Subtracted from. Just like the less than, if you use the phrase or see the phrase subtracted from, it switches the order. Because what you're starting with is listed second. 10 subtracted from 8 means you have 8. You're subtracting 10 from that, -2. Whereas 10 subtracted by 8, you've got 10 subtracted by 8, +2. So those two get the star. But yes, minus, if you want to add that in there too, that works. 2 more spots. Who wants to fill them? We can fill them all. Yeah. Anyone? Yeah.
For addition plus.
Plus, might as well.
Add another box.
Okay. For multiplication, let's add the word groups. groups of, okay? Groups of, when you are, if you have 3 groups of 4, you've got 12 in all. And then for division, the into groups. Into groups. Like when your teachers have you divide into groups of 4, you are taking the class total and dividing yourselves into groups of a specific number. Okay? So the word groups can be tricky too, because it can work with either multiplication or division. You have to look at what other words are around it. Okay? The context there. Questions on the table? This bring back fond memories from pre-algebra?
Yeah.
It was like CO14 or something like that, right?
That was scary.
That was.
That wasn't scary.
So here is what you are to do. It says write the verbal phrase as an expression and then evaluate when n equals 2. So if there's a variable, which most of these probably have, then you need to evaluate that expression when that variable equals 2. So the quotient of 16 and a number, how would that be as an expression? Yeah. Right, and what's your keyword there that tells you it's going to be division? Quotient, okay? Quotient of 16 and a number. You can either write that horizontally, which is not that, that's vertically. If you want to write it horizontally, then you can, okay? Both work, 16 divided by n. And then if n is 2, what's the value of it? It is 8. Very good. That's all you got to do. Okay? We're not to the back yet. We're still on this. Any others on this page that you want to go over here? Yeah. The total of 22 and a number divided by 6. So we've talked about all the main 4 operations here. We didn't talk about exponents, radicals. We'll get to that later on. But we didn't talk about parentheses. Okay? How do you know when you're going to need parentheses when setting up an expression from a word problem? What are you looking for, Priya? The comma, right? That comma is the literary use to separate operations or separate expressions within a larger one, right? It says the total of 22 and a number, comma, divided by 6. This is important. If I just said the total of 22 and a number divided by 6, you could think that means 22 plus a number divided by 6. Because you can't really hear a comma unless you really accentuate it. But when I read it as the total of 22 and a number divided by 6, now you say, oh, the total of 22 and a number comes first, and that is divided by 6. So commas are a way to introduce parentheses to an expression. Okay? Yeah. Let's finish off first because we have to evaluate this when n is 2. I wrote it horizontally here. You could also write it 22 plus a number divided by 6. Here you would not need parentheses because of how I wrote it. When you write division vertically like a fraction, it's understood that there are parentheses around the numerator and the denominator, even though they're not written. Okay? So if you've got something against parentheses, you can work your way around them by writing it as a fraction. You don't need to actually put them there, but they're still there. And what is the value? 8. 4. 22 plus 2 is 24 divided by 6. 4 here, 22 plus 2, 24 divided by 6, it still equals 4. Okay? Question or next one? Because Evelyn's in the docket.
I just want to know the next one.
Okay, we're going to do, yeah.
10 times the quotes. Does twice the sum of a number and 6.
Is that above? Twice the sum of a number and 6.
It's like multiplication.
Twice the sum of a number and 6. Let's break this down. Okay? Give me a key word that you see here, and what does it mean? Evelyn. Sum means what?
Addition.
Addition. So we know we're adding something. Okay? Chance?
twice would mean there's 2.
Twice means that we are specifically multiplying by 2, right? It means that we're multiplying, but specifically by 2. And then, of course, we have a number which we'll use n. Then we have 6, which we'll use 6. So those are kind of the players here, right? We're taking twice the sum of a number and 6. Now, the use of the word sum is important here because what is sum? Yes, it's addition, but what does it truly mean? Yes, sum means the answer to an addition expression, right? So if we're taking twice the sum, there are no commas here, but the use of the word sum tells us that we need what? Parentheses. We have to know what the sum is first before multiplying by 2. Okay, so sum or product or difference or quotient are sneaky words that can be used that mean parentheses because they literally mean the answer to. We want to take the answer to a number in 6 and then take twice that. Okay? So, what is this equal?
16.
16. 2 plus 6 is 8 times 2, it equals 16. Okay. I'm going to do the rest of them on your own. We've done kind of 3 of the more challenging ones here. Yeah, half the difference of third-degree number. Just think what half means. Think what difference means. Difference is the answer to a subtraction, right? We have less than, that phrase there. Okay, don't forget to star that one because that one can be a little bit tricky. On the back side, we go the opposite. On the back side, I give you the numerical, and you need to write the verbal, and then again, evaluate when n equals 10. You can evaluate before you write it as the verbal. This is just practice plugging values in, things like that. These will have many different answers, right? Because for 8 plus n, you could write 8 plus n. You could write 8 added to n. You could write the sum of 8 and n. 8 more than n more than 8. There's lots of different ways you could write that. So this one, they'll have lots of different answers for. You can use commas where you need to. Hugo?
Yeah, for this one on page 2, we have to do like for n, we have to put a number.
You can put n. Yeah, that's all right. You can put n. Spirit of Christmas.
Could we do one of these?
Yeah.
It's September.
Oh, Spirit of Christmas? See, think about how joyous things are during Christmas time. If people acted so giving, so kind, so generous year-round in the spirit of Christmas, think much better.
Yeah, no, that's I made Halloween cupcakes yesterday.
People are happy when they get their candy. They're nice.
I made pumpkins.
It's just a better feeling that people tend to be more generous, kinder, more patient. And when they're acting the spirit of Christmas, I think we did that year round. I mean, it shouldn't take a special holiday to be nice to someone, right? We should do that all the time. Which one would you like to do together? Who asked for? Yes, Ace.
All of them.
No.
Oh, on this one.
Yes. Oh, yeah.
The 43 and
Yeah, the last
what I was
one.
saying.
Yeah, that's the. There we go. All right.
43
So
minus.
let's dissect this here. We have 3 operations. We've got subtraction, we've got division, we've got addition. The parentheses tell us that we have to break the order of operations here, right? We have to somehow show in our verbal phrase that we were not going to be dividing first. Okay? So we could use words like sum and difference. We could use commas. Both are appropriate. What do you think, James?
I think it's 43 minus n, and then comma, divided by what? 6, comma.
Ooh, the double comma. Is that even legal?
I don't know.
It is, yes.
In some
5 plus 6.
Good. 43 minus n divided by 5 plus 6. Excellent.
You have to put the double comma.
You do need the double comma here, yes.
Oh,
Okay.
yeah.
Because you have two sets of parentheses, both must be done before the division. That division must be separated from the two operations. Who can write this without using commas, but still letting us know that there are parentheses there?
I don't want to do that. That's too much.
You go?
The sum of the difference of 43 and 5 plus, I don't know.
I think you said there were some, perhaps you meant quotient.
Oh, yeah.
Maybe? The quotient of the difference of 43 and a number. Technically, you would need a comma here just to kind of separate the numerator from the denominator. And the sum of 5 and 6. But it's fewer commas, so that works. It's fun. The quotient of the difference of 43 and a number, and the sum of 5 and 6.
That's a lot of words.
It is. Anybody else have any ideas for a commaless verbal phrase here? Yeah. How about the difference of 43 and a number divided by the sum of 5 and 6?
What?
The difference of 43 and a number divided by the sum of 5 and 6. Because the difference means you have to get that answer first. Divided by the sum means you have to get that answer first. Okay? So just kind of rewording what you had written there, I think would be a commaless way to write it. But
What does commaless mean?
without commas,
Oh, I thought you were saying it as one word.
I am.
Commaless.
It is like
Commaless.
No, but that should be 2 words.
Why?
no comma dash.
Comma dash. Comma dash.
What about like,
Like boy dash, but comma dash. For the character, not the word.
what if you're classless? Is that 2 words?
Yeah.
Yeah.
What?
What if you are homeless? Is that 2 words?
No.
So I think commaless.
Did you check the dictionary?
No. I find that I'm right a lot more often if I don't fact check what I say.
That's great.
Okay, your parents devise a plan for your allowance. They will give you $1 more than double last month's allowance. Here's your expression: $1 more than double last month's allowance. $1 more than double last month's allowance. Complete the table, following the rule. Then write an expression that models how your allowance increases from one month to the next. Question or answer?
I know like the rule.
I want you to write the rule, but I will ask you to help us fill up the table. If you get $1 in January, what is your allowance going to be in February if you get $1 more than double? Yeah, $3, right? $1 more than double, you're going to double the 1. That's 2. $1 more, that's 3. How much you get in March? 7. $1 more than double last month's allowance, right? If you got $3 in February, $1 more than double that would be 7. How much in April? 15. Now we're talking. You know how many tacos you can buy with $15?
I'm so confused.
Like 15.
31.
Wow.
31.
Evelyn, 31. Yes. Okay. You can finish out the rest. That's right. The rule on the table. What's your question, Aiden? Okay.
You're gonna get a lot of money.
What's that? So writing the rule is going to be how do you get from 1 to 3? How do you get from 3 to 7? How do you get from 7 to 15, 15 to 31? Just how do you get from 1 month's allowance to the next? Something like that. Test it, see if it works. But that's the right idea. Okay. This is due tomorrow. All of CO4. Expect a homework check tomorrow. You've got your bell ringer to go back in and fix. You've got the math packet due tomorrow as well. Some of you already have that done. If not, you've got a little bit of extra work tonight. But tomorrow. Yeah.
After a few years, we're gonna be getting a lot of money.
That is a good thing. Yes.
For the math,
We just have to fill out the table, right?
Folks, a question about grading the packet. For the math packet, to get full credit, you have to get 9 out of 10 correct. And then it decreases by 5% for each incorrect page after that. So for example, if you get a 9 out of 10, it's still 100%. And 8 out of 10 is 95%. 7 out of 10 is 90%, and so on and so forth. Okay? So a 9 out of 10 is 100, and it goes down by 5, each question incorrect answer after that.
Oh, I got it.
Anything else? Okay, homework due tomorrow, that's my math.
I'm done.
I got it.
to like and subscribe.